Blockchain deployment is not one size fits all. Public, permissioned, consortium, and hybrid networks each balance openness, control, privacy, scalability, liquidity, and compliance in different ways. As we move through the module, focus on one question. How does the network architecture shape digital asset issuance and settlement? You've already built the foundation: market context, architecture, operating flows, compliance, and decision records. Now we shift from what the issuance platform must do to where and how its blockchain layer should run, before we compare specific platform options. Think of the deployment model as an architecture decision, not just a blockchain preference. Public networks provide broad reach, liquidity, and composability, but give you less control over validators, fees, privacy, and upgrades. Permission networks reverse that trade-off, offering stronger privacy and governance with more operational responsibility. Consortium models share control among trusted parties. Hybrid designs connect private workflows to public settlement or liquidity. The right choice depends on access, validation, control, compliance, and cost. Public blockchains are built for open reach, not centralized control. Anyone can connect through wallets, APIs, exchanges, or applications, and the ledger is replicated across many independent nodes. That decentralization reduces reliance on a single operator, but it also moves key variables outside your direct control: fees, congestion, finality, and validator behavior. For digital asset platforms, the question is not simply, can we launch publicly? It is, what controls do we need around privacy, compliance, and operational reliability? The strength of public chains is that they bring both a shared market and a shared toolkit. Liquidity can make tokenized assets easier to reach, price, and trade. Composability lets those assets connect to wallets, custodians, exchanges, analytics, and settlement systems. Transparency supports public verification and stronger audit trails. Mature ecosystems also provide standards, SDKs, monitoring, and security practices, helping teams move faster when privacy and regulation are handled carefully. That openness comes with constraints. Gas fees can be unpredictable, especially during congestion. Public transaction histories may reveal investor or issuer behavior unless privacy is engineered in. Throughput may require batching, layer 2s, or careful transaction design. Regulators will also expect controls for identity, sanctions, transfer limits, and dispute handling. So the key question becomes, can we operate this safely, predictably, and compliantly? Permissioned blockchains take the opposite approach. Participation is controlled from the start. Each organization is identified, approved, and assigned specific rights before it can submit transactions or operate infrastructure. Validator or ordering nodes are run by trusted members, not anonymous miners. Governance defines who can join, how upgrades happen, and how disputes are handled. Because identity, privacy, and compliance are built into the architecture, these networks fit enterprise settings where trust exists, but still requires rules, auditability, and shared control. A consortium network sits between a fully private system and an open public chain. No single institution owns the entire environment. Instead, banks, custodians, issuers, and market operators share decision rights through agreed governance rules. Those rules cover who can join, who validates transactions, how upgrades happen, how disputes are resolved, and who can access data. The benefit is shared trust and reduced single-party control. The trade-off is coordination. Legal, operational, and technical alignment must be maintained over time. In enterprise digital asset networks, privacy is not a single switch. Different facts need different levels of visibility. Investor identity, holdings, trading intent, and settlement details may be restricted to authorized parties through private channels, data collections, or encrypted payloads. At the same time, the system must preserve evidence for compliance. Selective disclosure and zero-knowledge proofs allow regulators to verify required conditions without exposing everything. The goal is confidentiality with auditability, not secrecy without accountability. More control also means more operational responsibility. Nodes must be patched, monitored, kept available, and recoverable. Contracts, rules, and memberships need defined change processes. Security teams need disciplined handling for keys, certificates, access, logs, and incidents. And resilience cannot depend on one participant. It must be agreed, tested, and governed across the consortium before production traffic relies on it. Hybrid designs give regulated platforms a way to split responsibilities across environments. Issuance, compliance, and audit can remain in a permission network where access and data controls are stronger. A public chain can then provide anchoring, settlement, stablecoin connectivity, or independent proof. The challenge is operational. Identities, asset states, hashes, and lifecycle events must reconcile across both networks. Hybrid architecture is powerful, but only when synchronization is treated as core infrastructure. One common hybrid pattern separates control from liquidity. The asset is issued inside a permissioned environment, where KYC, eligibility, and transfer rules can be enforced. The cash leg settles on a public blockchain using stablecoins, tokenized deposits, or digital cash. The integration layer is critical. It must coordinate delivery versus payment, confirm finality on both networks, handle failed settlement, and keep compliance teams, monitoring systems, and reconciliation ledgers aligned. Another pattern is public anchoring, which separates proof from data. The private system keeps the actual records, then generates a hash or commitment and writes that proof to a public chain. Later, an auditor, regulator, or counterparty can recompute the proof and confirm that the record existed at that time and has not changed. Selective disclosure adds control, so each verifier sees only the fields they are entitled to see. The operational discipline matters. Evidence storage, proof generation, verification, and retention all have to work reliably. Choosing an architecture is less about finding the best network and more about finding the right fit. Public networks favor liquidity, interoperability, and broad ecosystem access. Permission networks favor privacy, control, and governance. Consortium models work when several institutions need shared infrastructure and mutual trust. Hybrid designs help regulated workflows connect to public chains without giving up controls. A practical approach is to weight the criteria, score the options, and make the trade-offs explicit. The main lesson is fit. Public, permissioned, consortium, and hybrid networks each trade off openness, control, privacy, coordination, and settlement reach. As architects, we match those trade-offs to regulation, stakeholders, operations, and strategy. Next, we move from network models to specific platforms and compare leading options.